Hey there, pre-calc friends. Welcome to the end of section 4.4, where we finished off the law of sines, but specifically we're working with this very strange ambiguous case that we hinted at before, and we looked at some diagrams, but now we're going to put the math to it. So just a review of the diagram, here's what's happening here. You're given a triangle that we need to solve, but here's what you're given. You're given angle A, as you see here. You're given a side B, and you're given this side A as well on a typical triangle ABC. Now, if you look around and you want to figure out what case this is the infamous SSA case. It's not side angle side because the angle is not in between the two sides. It is outside of those two sides there. So this is SSA, so we have to be very, very careful. When you see that, a little red light's got to go off in your head thinking, uh-oh, this is going to be the ambiguous case. We have to be really careful. Again, here's why. The way we drew it right here in the diagram, you can see that we have one smaller triangle right here, and we could probably solve it using law of sines. But, however, what if I took that side A that I have over here on the right, and I swing it over here? I'm not going to change the length of it, but I'm going to swing it over here, and this is the same length A over here. Now that you see that if I have that A, same length as before, and the B that was over here, and the angle A, I actually have a completely different triangle. Look at this triangle. This is now the new big ABC. That also could exist. Big triangle number 2 here. So it's very possible with this strange law of sines with the ambiguous case, SSA, you could get one triangle, you could get two triangles, or it's very possible, I'll show you later, that maybe, by chance, you draw everything as we see here. Let me show you if I clear it all off. What if the original A, B, and C were given to you? Here's angle A, here's side B, and here's side A. But what if, I'm just going to redraw side A, what if side A was only about this long? So you were given side B, angle A here, but side A actually wasn't long enough. And you can see here it's not going to be long enough to actually connect all three sides and make a triangle. So is it possible you could actually get 0 triangles out? And we'll try to show that a little bit later too. So this is the ambiguous case, and because it's ambiguous, we could get maybe one triangle, two triangles, or perhaps none. We're going to go through each of the examples so you can see. So take really good notes and follow along. It's actually not too hard, and I'll show you a couple ways to do it. Here we go. Let's try example number 1. So again, we're given triangle ABC, and the best thing to do with all of these folks is always just draw the triangle with what you're given so that you know that we have this special ambiguous case. Because maybe we don't. If we don't have the ambiguous case, we don't have to have this conversation. We can just treat it like a normal law of sines or cosines. All right, I'm given angle 31 here for A. I'm given side A across from angle A is 16, and side C across from angle C is 20. We look at the case. Can you tell? It is the strange SSA. So right away, lights off in your head. Tread softly and be careful. Okay, so we know we're going to be using our normal law of sines. Just to recap really quick. And we're going to need our graphing calculator near us too, so make sure you do. Make sure your calculator is in degree mode. All right, let's see what we have here. Well, I need opposites, right? I need to have both A and A, or B and B, or C and C to be able to work well with this. So if I look right now, I do have angle A and side A across from each other. So I know that I can definitely use this fraction to start with. And then I'm also given side C over here. So I have that over here on my equation. I've got C. So maybe I can pair up these two fractions together. Shall we try? Here we go. So we're going to do sine of A, which is 31, over side A, equals sine of, well, angle C I actually don't know, so I'm going to leave it as C, over side C, which I do know is 20. So as you see here, the thing we're actually going to solve for is not a side, but an angle. Let's see if you remember, how do we used to solve for trig angles? All right, so as usual, let's cross multiply, and we get 20 sine of 31 equals 16 sine of that angle C that we're looking for. And remember, a good tip is don't plug anything into the calculator yet until your last step, just so you don't make any rounding errors too early. Okay, now C is what we're looking for. We're trying to get C by itself, which means really, I need to isolate this whole term, the sine of C. Once we get that by itself, then we can find another way to get angle C by itself. So right now, as you see, it's being multiplied by 16. So how about we divide both sides by 16? And we would get sine of angle C equals, how about 20 times the sine of 31 degrees, all divided by 16. Great. No calculator yet. Hold on. But do you remember, friends, in order to get the C by itself, we need to apply the inverse. We always use inverses for solving angles. So if I do it to the left side, I have to do it to the right side, so it balances out. On the left side, that destroys my sines, and I'm just left with C equals, how about the sine inverse of this whole expression, sine of 31 degrees divided by 16. And this is where your calculator comes in. You can punch it in right away as one big statement, sine inverse, and then plug in what's inside the fraction. And if I do that right, I get C is about 40.1 degrees. Great. Okay, so make sure that looks okay. And I've got C is 40.1 degrees. And now, this is the important step right here, folks. Ready? This is huge. This is where you stop. Stop right here. And we're going to determine right now, after finding the first angle, how many triangles do we have? Now, in some textbooks and in some YouTube videos, if you watch them, they'll do a different way of trying to figure out how many triangles. What they'll do is, over in our triangle over here, they will draw a perpendicular height that they're going to call H. And they'll come up with some interesting, and it actually is kind of cool, relationship between H and the length of A and the length of C. And it's something really interesting where, you know, if H is less than C but it's greater than A, then you get two triangles, something really interesting like that. And that's a really cool idea, and that does work really well. So if you like that idea, try that. The only reason I don't like it is because it's extra work, and the way that I try it is a little bit easier and straightforward. But it is different. So make sure you really follow along and take good steps. But if you like the other way where you find that perpendicular height H, go for it. It's absolutely fine. Now, here's the big step. This is where we need to figure out how many triangles. So after the first angle is found, let's go over here and have a little conversation. Ready? Okay. In triangle number 1, since we might have more than one, here's what we're going to do. What were you given? What was your given angle in the problem? Do you remember? It's right up here. Oh, it was the 31 degrees, right? That was given to you. That's set in stone. So you know that's going to be in the first triangle. Now, what did you just find? You just found angle C. And how much was angle C? That was 40.1 degrees. Now, my question for you is there room in this triangle for a third angle? Meaning, is there enough room in there that we can get a number but not bust the 180 degree ceiling? Remember, all triangles add to 180. So does that work? And actually, if you think about it, yes, it does. There is another angle that would fit in there. So triangle 1 totally exists. Check. Now, let's do the same idea with this possible triangle 2. Do we have a triangle 2? Let's check. Okay, what we're going to do is, let's still stick with the same given. You were given 31 to start with. That's in both triangles if it exists. Now, here's the weird part. Ready? It's possible that not 40.1 degrees, but its supplementary version might be in the second triangle. And where did I get that from? Do you remember in this triangle over here, we said that this is your angle that you first solved for, but maybe you could actually get this angle out as a possibility. And if you want to figure that out, what we do is, if you take your angle B and subtract it from 180, you would get this friend here. And because this triangle here on the right side is isosceles, the angle that you get here from subtracting from 180 is the same as the other possibility for the B. Okay, blah, blah, blah theory. The trick is, take the angle you found and subtract it from 180. So we're going to do 180 minus your found angle. Meaning, how about 180 minus 40.1? What would that be? What would that be? What would happen if that was in a triangle? And if you do 180 minus 40.1, you would get about 139.9 degrees. Okay, same question. Are you ready? Same question. Do we have enough room in this triangle with this angle, the 180 minus your found angle? Is there enough room in there that we're not busting the 180 degree limit? And it's going to be a pretty small angle, but I tell you, it does work. There is another angle in there. And because there is another angle, triangle 2 also exists. Okay, and that's the test that we do. We don't have to do this perpendicular height thing. We just do a little check. So let me review it one more time with you. In triangle 1, you take the given angle that you started the problem with. You take the angle that you just found right over here before you stopped. And you see, with those two angles in mind, do I have enough room in that triangle for a third angle? And yes, I did. So triangle 1 exists. To see if triangle 2 exists, what we did is, again, we take the given angle that you started with. We're going to subtract the found angle by 180. And see, does that angle here, 139.9, does that angle exist in the triangle? With that in mind, do I have enough room for a third angle? And yes, I do. And because of that, I do have two triangles that exist. So good news, we figured it out. The not so good news, well, we still have to answer the question. So we need to find what is the answer to both triangles. But that's the test that we do. Ready? Let's do it. So now, because there's two triangles, guess what? We're going to have two triangle answer boxes. But the good news is, whatever you were given in the original problem is going to be in both boxes because it's in both triangles. So here's triangle 1. Here's triangle 2. Okay, remember what you were given? You were given that A was 31 degrees from the beginning. Let me double check. There it is again. Okay, so I'm going to put that in both boxes because it's in both this triangle and this triangle. Because you were given, that's not going to change between the two triangles. You were also given, if you remember, that side A was 16 and C was 20. So that means it's the same in both triangles. If it's given, that is set in stone. Okay, our job now is just to find then all of these other ones that are missing. Now, you already found it up here. Remember when you found angle C in the first triangle? That was 40.1. I'll put that in there for angle C. Great. And now, remember how we can find angle B from that? We can just subtract everything from 180. And you should get this other angle should be 108.9. I just subtracted my 31 and 40.1 from 180. Notice we're using just one decimal place because it works best. Now, in the second triangle, let's talk about angle C. Remember we did this little test over here? Right there. How we subtracted from 180 and we got 139.9. Because that triangle exists, that angle exists, so we're going to put it there. That is your other version of angle C. It was either the 40.1 or we did the 180 minus it and we got this version. So that's the other angle C in the other triangle. Okay, knowing that, we can then find the other angle B in this triangle by subtracting from 180 again. Remember we said it was small, right? It's 9.1. And now you're almost done. All you have to do now is just find these last two B's. Now because the angle B is different each one, the side B's will be different. So you need to set up another law of sines twice to solve for it. Okay. So we definitely need to use the B's. I'm going to use sine of, in our first triangle over here, sine of 108.9 over the opposite side B, which I'm looking for. And now we notice we do have both C's and both A's. But you know what? I was given the A's. So why don't we always use the given? It's also not rounded, so you'll get more precise answers. Okay, folks, I'll give you a second. You can solve that by cross-multiplying and solving. But let me set up the other one, the other law of sines in this triangle. It's going to be very similar, right? It's going to be sine of, now B over B, but the B is different, right? All right, over, again, we got the A's, so why don't we use the A's? Okay, cross multiply, folks. Go and try that on your own, and we'll check our answers at the end. Good luck. Okay, if you did it right, I got that over here on the left side, side B should be 29.4. And on the right side, when I solved that one, B was 4.9. Now let's put it in, and we'll do that little geometry check. Remember we talked about that before, where we'll see if the longest side is across from the largest angle, and the shortest side is across from the smallest angle. Ready? Let's check. In triangle number 1, let's take a little peek over here. Can you find the largest angle? Longest side? Yes, yes, they match. How about the shortest and the smallest? Smallest angle I have is 31 degrees, and sure enough, my shortest side is 16. So that's a really good chance that you did it right if that geometry check works. Let's go over to triangle number 2, shall we? Same idea. Now, where's the biggest angle? That's angle C, right? What's your longest side? Sure enough, it's side C. How about smallest angle? I got 9.1. And sure enough, folks, the smallest side is opposite of that. So good way to double check. So as you see here, folks, this was the example of a 2-triangle case where you solve for the first angle right away using law of sines, but then you stop. And we do this little check over on the left-hand side. Great. Let's try another one. Okay, new example, new numbers, but again, same ABC triangle. Should we fill it out and sketch it? Let's do it. Okay, here I have angle B is 110. I have side A across from angle A is 4. Side B across from angle B is 11. All right, so now what case do we have here? Let's check. It is the infamous SSA, so just be careful. Important that we made that check. Okay, so let's do the same steps. Let's solve for the first angle. We'll stop. We'll do the check for the number of triangles, and then we'll keep solving. Okay, so ready? Let's say, again, we've got our law of sines, but I see that I have the B's are there, so I'm going to use a B over B. How about sine of angle B over side B equals, well, we need angle A because that's across from side A, and that's what we're given. So let me use that. So how about sine of angle A, which I don't know, over side A, which is 4. Okay, same steps, cross multiply. And if you do it right, angle A should be, remember how we're going to use the sine inverse, right? Okay, I'm going to just pause for a second to see if you can get there before I do, before I write it. But you cross multiplied, you get the sine A by itself, and then you're going to take the inverse to kill off the sine. And on the right side, you should have, ready, sine inverse of, how about 4 times the sine of 110 degrees divided by 11. Did you get that? If you did, great job. That means using my calculator again, in degree mode, A should be equal to, well, about 20 degrees. Very nice. So far, so good? All right, you know what to do. Stop. Stop, stop. Now we got to do our check. So you found your first angle. Let's do our little check. Ready? Have our little conversation, little powwow off here to the side. Okay, in triangle 1, remember how we write this? We said you were given which angle? You were given B, right? You were given 110. What angle did you just find? You just found the 20 degrees in A. All right. In that triangle, folks, is there enough room for a third angle to make 180 degrees? Yeah, absolutely. Absolutely. So that triangle does exist. Good. We definitely have one triangle. Ready? Here's the second triangle check. Remember what you were given? You were given 110, so that's solid. And now, here's the trick. Remember, we take the 20, and we're going to do 180 minus it to see if its supplementary also works when we swing that side over like we saw in the diagram. That is 160 degrees, right? 180 minus 20 is 160. Okay, let's do that check. Ready? So, is there enough room in that triangle to make 180 degrees, or did we break the limit? And as you see, we broke the limit. Can you see? That's 270 degrees. We can't have an angle that would fit in there unless it's negative, and that doesn't really work in trig. not in triangles at least. So if that angle doesn't exist, you know what? That triangle doesn't exist. So how many triangles did we actually find? Just the one. This is an example of a one triangle case. You tested for both, but in the second one it doesn't work because it would be too big of a triangle. It would not exist. Okay, so side angle, ambiguous case, here's a one triangle case. So let's go ahead and solve it. But good news, we're only solving for one triangle here, folks. Okay, remember what we were given? We were given up here on the top 110 for B. We're given side A was 4 and side B was 11. All right, so let's solve for all the rest. Now, when we did the check, we found that angle A, actually before we did the check, we solved for angle A and we got 20 degrees right up here. Great. Which means we can find the other angle C, right? Let's just subtract from 180. All those two angles, and now we get 50. Great. All right, all we got to do is then is just solve for one more side, law of sines. I'll set it up for you. Again, we do have all A's, but I want to use the B's because it was given. So sine of 110 over 11 equals sine of 50 over side C. All right, same steps, folks. Cross multiply, get that C by itself, and I'll check with you when you finish. And if you did it right, I got C was equal to 9. Okay, should we plug it in? Let's do that geometry check. Ready? All right. Largest angle, 110. Longest side, across from it. Smallest angle, 20 degrees. Shortest side, across from it. So it does work out, folks. Great job. You solved this one too. SSA now. 2 triangle case, 1 triangle case. What's left? What happens if there's no triangles? This is our last example for today. Let's draw the triangle. This one's kind of nice, actually. A, B, and C. Given here, I'm going to give you angle B is 82 degrees. I'm going to give you side A is 34, and side B is 22. As always, check your case. And this one is the infamous SSA, so be careful. And again, if you don't get SSA, if you get SAS or ASA or anything different, you don't have to worry about this check. It's only if you get SSA. All right, ready? So let's set it up. Notice what we have. We do have the B's, so I'll use a law of sines for B's, and I'll match up with the A's so I can try to solve for angle A. Here we go. Sine of 82 degrees over 22 equals the sine of angle A, which I'm trying to solve for, divided by side A. Okay, as always, we're going to cross multiply. Get the sine A by itself, take the inverse, and angle A should be the sine inverse of, did you get it? How about 34 sine of 82 degrees divided by 22. All right, hopefully you got the same spot. Let's punch into the calculator and see what happens. When you do that, you punch it in and something crazy happens. Did you get this? If you did it right. What happened, folks, is you have a triangle here that has the side and the angle of 82 degrees, but for some reason, perhaps, maybe it's just not long enough. It doesn't actually make a full triangle for some reason. By the side angle that you're given, it can't compute the triangle and it can't solve for it. This is an example of 0 triangles. If you ever punch in your inverse there to solve for the angle, and you get an error, you did it right. That means there's no triangles, nothing exists. And that's wonderful news because we're done. We don't have anything to solve for, so we just move on. Basically, mathematically, why is that? We're going to talk a little bit about later, but we can only take the inverse of sine if the numbers inside there are between 1 and -1. But again, we'll talk about that when we get into chapter 5. But if you have a number that's not in between 1 and -1 inside that parentheses, when you try to calculate it, it's going to say error. It's not going to like it because it doesn't exist. But basically, you do the check. You solve for the first angle. You got an error. Oh, no, it doesn't exist. That means the angle doesn't exist, which means the triangle doesn't exist. And we are so happy. So there you go, friends. So again, here was a 2-triangle case. You do the check. A 1-triangle case, you did the check, but that triangle didn't work. And eventually, the 0-triangle case, because the angle does not exist. There you go, folks. There is side-side angle for law of sines, the ambiguous case. Great job. We'll see you next time.